Welcome back to Snooze to Astronomy. Tonight we will be easing your mind for true transcendence with 101 facts about black holes. So lay back, close your eyes, and enjoy the video. Black holes begin as the corpses of massive stars. When a giant star runs out of fuel, it can no longer resist gravity's pull. Its core collapses under its own weight, and if the mass is great enough, nothing halts the fall. Space itself caves in, creating a point of infinite density. A singularity. At the heart of every black hole lies this singularity, a place where the known laws of physics break down. Space and time curve so violently that our equations fail, leaving a mystery beyond comprehension. The singularity is hidden from sight, wrapped in the black hole's defining boundary, the event horizon. The event horizon is not a physical surface, but an invisible point of no return. Anything crossing it, matter or light, is lost forever to the outside universe. To an observer, it appears as a dark sphere, a shadow against the backdrop of stars. Yet inside lies a region where reality itself dissolves. Black holes bend light with their immense gravity. Like cosmic lenses. This distortion can make stars behind them appear stretched into arcs or duplicated, a phenomenon called gravitational lensing. In this way, black holes do not just devour light, they sculpt it into strange, warped patterns across the sky. Time behaves strangely near black holes. To someone falling in, time feels normal, flowing steadily toward the singularity. But to a distant observer, that fall appears to slow endlessly, frozen at the event horizon. Black holes are clocks that disagree, demonstrating Einstein's relativity in the most extreme way. Not all black holes are the same size. Stellar black holes form from dying stars, weighing a few to dozens of suns. Supermassive black holes, millions or billions of times heavier, sit at the centers of galaxies. In between may lurk intermediate black holes, cosmic middleweights that bridge the gap. Our own galaxy, the Milky Way, harbors a supermassive black hole called Sagittarius A*. For 1,000,000 times the mass of the Sun, it anchors the galactic core. Stars whip around it in dizzying orbits, silent dancers circling an invisible stage, proving the presence of an unseen titan. Black holes are not cosmic vacuums, sucking everything in. You could orbit one safely if you stayed outside the event horizon. Just as Earth orbits the Sun, the danger lies only if you stray too close, where gravity steepens to a deadly plunge. Their reputation as unstoppable eaters hides a more nuanced truth. Matter falling into a black hole does not always vanish quietly. As gas spirals inward, it forms an accretion disk, heated to extreme temperatures by friction. This disk glows brilliantly, often outshining the galaxy around it. Paradoxically, the darkest objects in the universe can be surrounded by dazzling light. Some black holes launch jets of particles at nearly the speed of light. These beams, shooting from the poles, stretch across thousands of light-years, carving through intergalactic space. Their origins remain mysterious, but they reveal black holes not only as destroyers, but as engines shaping galaxies. If you approached a black hole feet first, you would experience spaghetti. Gravity would pull harder on your feet than your head, stretching you like a strand of pasta. Closer still, the difference becomes so extreme that even atoms are ripped apart. Black holes do not simply consume, they shred. Black holes may grow by merging. When to collide, they produce ripples in spacetime called gravitational waves. These faint tremors race across the cosmos, carrying news of cataclysmic unions. Detected for the first time in 2015, they confirmed predictions made a century earlier by Einstein. Gravitational waves are unlike light or sound. They are distortions of spacetime itself. When they pass through Earth, they stretch and squeeze everything by minuscule amounts. Detectors like LIGO catch these vibrations, listening to the universe's deepest rumblings from colliding black holes. Hawking radiation, a prediction by physicist Stephen Hawking, suggests black holes are not truly eternal. Quantum effects at the event horizon allow particles to escape, slowly draining the black hole's mass. Over unimaginable timescales, black holes may evaporate, fading into nothingness. Small black holes would evaporate quickly, blazing away in bursts of energy. If primordial black holes formed in the early universe, some may already have vanished. Others, if they exist, could still roam unseen, smaller than mountains yet carrying the mass of worlds. Supermassive black holes likely grew from smaller seeds. devouring matter and merging with others across cosmic history. Their growth helped shape galaxies, influencing star formation. In many ways, galaxies and their central black holes evolved together, partners in cosmic architecture. The largest known black holes are giants beyond imagination, tens of billions of times the Sun's mass. They lurk in colossal galaxies, devouring entire stars with ease. Their event horizons are larger than the orbits of planets, swallowing space on scales that dwarf solar systems. Black holes are invisible by definition, yet we have imaged one. In 2019, the Event Horizon Telescope revealed the shadow of the black hole in Galaxy M87, a glowing ring around a dark void. It was humanity's first glimpse of the unspeakable, a portrait painted in radio waves. The shadow of a black hole is larger than the event horizon itself. Light bending around it creates a silhouette, a dark circle against glowing matter. This shadow is the calling card of black holes, a signature of gravity so strong that even photons cannot escape its grip. Black holes challenge our understanding of physics. At the singularity, general relativity predicts infinite density, but quantum mechanics demands a different explanation. Reconciling these theories, finding the true nature of black holes, may unlock the path to a theory of everything. Black holes can spin, and when they do, they drag space-time itself around with them. This phenomenon, called frame dragging, twists the very fabric of reality. Anything nearby, even light, is forced to swirl around with the rotation, caught in the cosmic whirlpool of a spinning black hole. The faster a black hole spins, the closer matter can orbit before falling in. A maximally spinning black hole allows stable orbits much nearer the event horizon. This means spin changes how black holes interact with their surroundings, influencing the power of their disks and jets. Inside the event horizon, all paths lead inward. No matter the direction you move, you are drawn to the singularity. Space is so warped that forward in time and toward the center are the same. A black hole is a trap not just in space, but in the flow of time itself. From the outside, falling into a black hole looks strange. An object appears to slow, growing dimmer and redder until it fades away. It never seems to cross the event horizon. But from the object's point of view, it falls freely, crossing the boundary without noticing until the end comes. Black holes can collide in spectacular fashion. When two spiraling giants meet, they fuse into a single, larger black hole. The collision releases more energy in gravitational waves than all the stars in the observable universe emit in light at that instant. These are the loudest events in space-time. Quasars are powered by black holes. These brilliant beacons, shining from billions of light-years away, are galaxies whose central black holes are feasting. Their accretion disks blaze so brightly they outshine the stars of their host galaxies, marking them as some of the brightest objects in the universe. Supermassive black holes might regulate starbirth in their galaxies. Their radiation and jets heat surrounding gas, preventing it from cooling and collapsing into new stars. In this way, black holes are both creators and destroyers, shaping the life cycles of galaxies themselves. Black holes come in different flavors. Stellar black holes are born from supernova. Intermediate ones may form from clusters of stars collapsing together. Supermassive ones dominate galactic centers. The possibility of tiny primordial black holes adds another layer, hinting at cosmic relics from the Big Bang. Black holes are the ultimate recyclers of the universe. The gas and stars they consume don't simply vanish. Their energy gets redistributed, sometimes powering jets that feed the surrounding galaxy. In this sense, black holes are not only destroyers, but also creators, shaping cosmic environments. Inside a black hole, the idea of space and time loses meaning. To us, time moves forward, and space stretches around us. But beyond the horizon, these concepts may switch roles. Time becomes a direction you can't avoid, while space folds into impossibilities we cannot yet map. The loudest collision ever detected in the universe came from black holes. In 2019, LIGO observed a merger that sent shockwaves through space-time. For a fraction of a second, it released more energy than all the stars in the observable universe combined. Some black holes are wandering nomads born from stars in disrupted systems. They drift alone through galaxies, invisible except when they pass in front of background stars. Astronomers estimate there may be hundreds of millions of such solitary travelers in the Milky Way. The center of the Milky Way is crowded with stars, dancing around Sagittarius A*. Their orbits, tracked for decades, confirmed the black hole's presence beyond doubt. One star, called S2, swings in close every 16 years, its motion proving Einstein right again. Black holes don't always grow by eating matter. Some gain size simply by merging with other black holes. Over billions of years, this process may create ultramassive black holes, heavier than anything we've yet discovered, lurking silently in galaxy clusters. If you fell into a stellar mass black hole, tidal forces would stretch you like spaghetti, but in a supermassive black hole, the same effect would be less extreme. At the horizon you might pass through without immediate harm, though your fate deeper inside is still sealed. Some scientists speculate black holes may connect to white holes, theoretical opposites that expel matter instead of swallowing it. Together they could form wormholes, shortcuts across the universe. No evidence exists yet, but the equations tantalize physicists. Jets from black holes travel at nearly the speed of light, piercing the cosmos like arrows. These streams can trigger the birth of stars in some regions, while stripping gas away in others. Black holes, paradoxically, regulate the growth of galaxies through such violence. In 2022, the Event Horizon Telescope revealed the shadow of Sagittarius A*, giving humanity its first direct glimpse of the black hole at the heart of our galaxy. Though blurry, the image confirmed decades of predictions, proving that even the darkest places leave their mark. When gas swirls into a black hole, it forms an accretion disk hotter than the sun's surface. These disks shine so brightly in X-rays that astronomers use space telescopes to find them. A black hole feeding on matter is often one of the brightest objects in the universe. Some black holes spin so quickly that their horizons flatten, bulging at the equator. These extreme rotations twist space-time itself, dragging everything around them in an effect called frame dragging. It's like the cosmos itself is forced to dance to their spin. The smallest possible black hole may be microscopic, yet as massive as a mountain. Such objects, if they exist, would curve space-time intensely. In a space smaller than an atom, they might evaporate quickly, but their discovery would confirm theories about the early universe. Black holes could play a role in dark matter theories. Some scientists propose that primordial black holes formed shortly after the Big Bang might account for at least part of the universe's missing mass, though still unproven. The idea remains a candidate for solving the mystery. Not all matter falling into a black hole is doomed. Some particles get accelerated outward instead of inward, escaping as high-energy radiation or cosmic rays. These bursts allow astronomers to detect black holes even without seeing the objects directly. If you could hover near the event horizon, you'd witness the universe speed up around you. Stars, galaxies, and even the far future would appear to race by in moments, while to you only seconds pass. A black hole is not just a trap, it's also a time machine. Black holes in binary systems often steal matter from their stellar companions. The gas forms a glowing spiral into the black hole, releasing bursts of X. These systems are among the first places astronomers identified black holes. Long before direct imaging, the heaviest black hole discovered so far weighs more than 60 billion suns. It lurks in a distant galaxy cluster, a monster so massive that its gravity dominates entire regions of space. Giants like this challenge our theories of how black holes grow so quickly. Black holes may never truly touch one another. Instead, their horizons merge smoothly, like drops of water blending. The singularities inside may fuse in violent, unknown ways, but to the outside universe, the event is seamless, marked only by gravitational waves. The end of the universe could be ruled by black holes. In trillions upon trillions of years, after all stars have burned out, black holes may be the last remnants, slowly evaporating into nothing. They are not only our cosmic predators, but also our universe's final survivors. Black holes may have formed moments after the Big Bang, when densities were so high that even tiny fluctuations collapsed under their own gravity. These primordial black holes could still be wandering the universe today, ancient relics older than galaxies themselves. The mass of a black hole is often measured through the orbits of nearby stars. Astronomers track their paths with incredible precision, and only the presence of an unseen, compact, and massive object can explain their dance. This technique gave us proof of Sagittarius A*. Some black holes flicker rhythmically as they feed. Matter falling inward creates quasiperiodic oscillations, patterns that can be detected in X. These cosmic heartbeats revealed the physics of matter teetering on the edge of destruction. Black holes can lock stars into deadly embraces. Some stars orbit so close that their outer layers are stripped away bit by bit, feeding the black hole in a slow motion devouring that can last millions of years. In the early universe, supermassive black holes already existed just a few 100 million years after the Big Bang. How they grew so quickly remains one of astronomy's greatest mysteries. Some theories suggest runaway collapses of massive gas clouds seeded them. Black holes aren't always hidden. Quasars, among the brightest objects in the universe, are powered by supermassive black holes feeding ferociously. Their light outshines entire galaxies, reaching us across billions of years. A black hole's gravity can distort the orbits of entire star clusters. Some globular clusters near the Milky Way's center are thought to be sculpted by the influence of Sagittarius A*, their shapes bearing silent testimony to its pull. Black holes may hold clues to unifying physics. The tension between relativity and quantum mechanics is nowhere sharper than at a singularity. Cracking the paradoxes of black holes might lead us to the long-sought theory of everything. Some black holes are dormant for eons, then awaken when a star wanders too close. This sudden feast unleashes tidal disruption events, flares that briefly rival the brightness of their whole galaxy, before fading again into silence. Some black holes may harbor entire solar systems orbiting safely outside their danger zones. In theory, planets could exist in these exotic systems, warmed not by a star but by radiation from the accretion disk. In the far future, black holes may become the last source of usable energy. Advanced civilizations could harvest their Hawking radiation, feeding on the faint trickles of power long after stars go dark. The mathematics of black holes hints at hidden dimensions. Some theories suggest their behavior makes sense only if extra layers of reality exist beyond our three-dimensional perception. At their cores, black holes challenge the definition of space itself. If the singularity is a point, it contains infinite density in zero volume, a concept that breaks our mathematics, urging us to invent new physics. Some black holes are born spinning so fast they approach the cosmic speed limit. Their rotational energy could power entire galaxies if harnessed. A staggering reservoir locked in space-time. Black holes remind us that endings are often beginnings. The death of a star becomes the birth of a black hole, which in turn reshapes its galaxy, influencing the stars and planets that follow. Even silence tells us about black holes. When regions of the sky go strangely dark, with less X-ray or radio emission than expected, astronomers suspect the quiet hand of a hidden black hole at work. Theorists dream of using black holes as gateways for exploration. If wormholes exist, they might be stabilized by exotic matter and linked to black holes, offering shortcuts across the cosmos or, perhaps 2 times long past or future. Black holes hold lessons about humility. They show that even the brightest stars can collapse, that light itself can be trapped, and that the universe is far stranger than our imagination dares. Yet, despite their menace, black holes sustain cosmic balance. Without them, galaxies might never cohere, stars might never form in ordered patterns, and the universe would look utterly alien. The journey to understand black holes is as infinite as the objects themselves. Each discovery spawns deeper questions about time, about gravity, about the very nature of existence. To study them is to follow a trail into the unknown. They are the universe's paradoxical guardians, yet preserving, consuming yet creating, ending yet beginning. In their shadows, we see both our limits and our potential, a mirror held up by the cosmos itself. And so, black holes are not simply holes at all. They are storytellers, engines, prisons, creators, and destroyers. They are the dark heartbeats of galaxies, the eternal echoes of stars, and perhaps the keys to the deepest truths the universe holds. The sound of a black hole merger, when translated into audio frequencies, is a chirp. As the holes spiral together, the pitch rises sharply before cutting off. We cannot hear it directly, but detectors convert space-time ripples into haunting cosmic songs. Galaxies without black holes may be rare. Even dwarf galaxies often hide small black holes in their centers, suggesting that these objects play a key role in galactic formation and stability throughout the cosmos. The spin of a black hole can determine how efficiently it feeds. Faster spinning black holes pull in matter more smoothly and can convert more of it into energy, creating brighter emissions. Spin is as important a property as mass in black hole physics. Black holes are natural laboratories for testing. Extreme physics. No particle accelerator on Earth can reach their conditions, but by studying their emissions, astronomers probed the limits of plasma physics, magnetism, and relativity. The Milky Way's black hole may have once been a quasar. Evidence suggests it was far more active in the distant past, blazing brightly before settling into the quieter state we observe today. Black holes create ecosystems around them. Stars, gas, and even smaller black holes can orbit in stable systems just outside the event horizon. These strange neighborhoods are some of the most extreme habitats in the universe. Some black holes kick their surroundings violently when they merge. Gravitational recoil can send the newborn black hole hurtling through space at thousands of kilometers per second, fast enough to escape its host galaxy entirely. The most massive known black holes outweigh entire galaxies' worth of stars. They defy easy explanation. How could something so colossal grow in a universe only 13.8 billion years old? These giants challenge the limits of astrophysical models. Black holes may connect us to parallel realities. Some physicists propose that what falls into a black hole could emerge elsewhere in a new universe, each black hole in our cosmos being a seed of creation beyond our reach in the farthest future. As black holes evaporate through Hawking radiation, they may release bursts of particles in their final moments. These last explosions of energy will mark the death of the last cosmic titans. To study black holes is to study ourselves. The elements that form planets, oceans, and life itself were forged in stars and spread by supernova. But black holes shaped where those stars formed and how galaxies grew. In their shadow, we find the story of our origins. The greatest mystery of black holes remains unsolved. What truly lies beyond the horizon? Are they endless prisons, gateways to other realms, or crucibles for new physics? Until we can peer deeper, black holes remain the universe's most profound riddle. Black holes may act as the ultimate storytellers of the cosmos. Every photon that grazes their edges carries information about the violent histories of stars, gas clouds, and galaxies. When astronomers decode that light, they uncover tales written across millions of years, preserved at the event horizon's edge. Some black holes are quiet for ages before suddenly roaring to life. As dormant beasts, they lurk invisibly at the centers of galaxies, waiting for a passing star or gas cloud. When the meal arrives, they erupt in flares brighter than anything else in the sky, reminding the universe of their latent power. If you were able to orbit just outside the event horizon of a black hole, you would witness a distorted universe. Light from distant galaxies would smear and stretch, stars would bend into arcs, and time itself would appear fractured. Space would feel like a hall of mirrors built from gravity. There is speculation that information, swallowed by black holes, might never truly vanish. Quantum theories suggest that data is somehow encoded on the horizon's surface, like cosmic graffiti written in the smallest possible script. This idea holography may hold the key to uniting physics. Superatoms of black holes can control the growth of galaxies by blowing winds across interstellar space. These winds, powered by jets and radiation, sweep gas away and prevent new stars from forming. Thus, black holes are galactic gardeners, pruning and shaping their hosts. A star destroyed by a black hole is said to be spaghettified. Its body stretches into long, thin strands as tidal forces pull harder on one side than the other. To distant observers, this looks like a stream of glowing matter unraveling into the darkness. Black holes could be surrounded by photon spheres, shells where light can orbit them indefinitely. A beam of light caught there could circle the hole countless times before escaping or being consumed, tracing impossible paths unseen elsewhere in the universe. The boundary of a black hole event horizon expands as it eats. Every atom of matter that falls in swells its surface, growing the shadow in subtle but permanent ways. In this sense, black holes are like living organisms, fattened by every morsel of the cosmos they consume. Astronomers once believed black holes would be impossible to observe, yet today we see their fingerprints everywhere. Warped starlight, flickering X-rays, distorted galaxies. What was once thought invisible now paints itself boldly across the fabric of the sky. The jets from black holes are so powerful that they can punch through the intergalactic medium itself, carving cavities in surrounding plasma. These cosmic scars, visible in radio wavelengths, testify to the immense violence unleashed by the hungry cores of galaxies. Black holes are thought to preserve angular momentum. As stars collapse, their spin compresses inward. The resulting black hole spins with staggering speeds, some rotating hundreds of times per second. This whirling motion drags space-time itself into a cosmic whirlpool, the sound of matter falling into a black hole, if translated into human hearing, would not be a roar but a rising shriek. As the matter accelerates and energy builds, the pitch climbs until it vanishes past perception. Black holes sing songs we cannot hear, yet their music moves the cosmos. Some black holes might wear cloaks of dark matter. Invisible particles could swarm near their horizons, subtly altering their growth and behavior. If proven, this would link two of the greatest mysteries of modern science in a single terrifying laboratory. Binary black holes can trap each other in a gravitational dance lasting millions of years. Their orbits tighten slowly as they radiate energy, spiraling inward like cosmic figure skaters. When they finally merge, the ripple shakes the very structure of the universe. The edge of a black hole is not uniform. It quivers with quantum fluctuations. These tiny jitters, invisible to us now, may hold the secrets of reconciling relativity with quantum theory. What looks smooth and perfect from afar is seething with restless energy up close. At the largest scales, black holes act like anchors in the web of the cosmos. Their immense pool holds galaxies together, preventing them from unraveling as they spin. Without these invisible centers, the night sky might not contain the grand spirals and clusters we admire. Some theories suggest that every black hole may be a doorway to a new universe. What falls inside may not be destroyed but reborn elsewhere, in a dimension beyond our reach. If true, then black holes are not just ends, but beginnings, cradles of creation hidden in shadow. The death of a black hole is slow, yet dramatic. Over unimaginable spans of time, it leaks radiation, shrinking little by little. When its mass becomes tiny, it will end with a final burst, an explosion of pure energy, the last firework of an object that once swallowed stars. Black holes may even help explain why our universe exists. Some physicists argue that the fine-tuned balance of constants is the result of cosmic evolution, where black holes birth new universes with slightly altered rules. We might live inside one such descendant reality. In popular culture, black holes are depicted as bottomless voids, but in truth, they are fountains of energy. The regions around them glow brighter than any star, feeding telescopes with light that tells us more about the universe than almost any other object. Black holes can act as cosmic timekeepers. By studying how matter orbits them, astronomers test Einstein's equations with incredible precision. These orbital motions, repeating like the tick of a celestial clock, confirm that relativity still holds even at the very edge of space and time. Some black holes roar with winds traveling at a significant fraction of the speed of light. These outflows of gas, heated and accelerated by magnetic fields, push back against their surroundings. Galaxies feel this pressure as though their hearts are breathing, exhaling across the stars. Black holes can masquerade as stars when paired in binaries. To the naked eye, the companion star shines brightly, but its wobbling motion betrays the invisible partner. By watching that dance, astronomers detect the hidden presence of the devourer. In the chaos around a black hole, particles are accelerated to extreme energies. Some may become cosmic rays, streaking across galaxies until they collide with Earth's atmosphere. Each one is a messenger from the dark frontier of the universe. The event horizon is not a wall but a horizon in the truest sense. Like a ship disappearing beyond the sea's edge, objects fade as they cross it, never to return. What lies beyond remains forever hidden, but the boundary marks the point of no return. In mythology and literature, black holes often symbolize fear of the unknown. Yet in science, they are gateways to understanding. By studying their shadows, jets, and orbits, we learn about the deepest structures of spacetime itself. Some black holes flicker like candles. As matter falls unevenly into their disks, the light output rises and falls, creating irregular patterns. These flickers provide clues about turbulence and magnetic storms raging at the brink of eternity. In galaxy clusters, black holes coordinate cosmic ecosystems. Their jets heat intergalactic gas, preventing runaway star formation. Without this balance, clusters would collapse into chaos, even in destruction. Black holes impose order on the largest scales. Astronomers use X-ray binaries to study stellar mass black holes. These pairs glow intensely as the black hole siphons gas from its partner star. The resulting emissions allow scientists to measure mass, spin, and feeding patterns with remarkable detail. The spin of a black hole can align with the galaxy around it, or oppose it. When aligned, jets blaze smoothly. When misaligned, chaos erupts. This cosmic tug-of-war shapes the evolution of galaxies across billions of years. Some black holes are so distant that their light has traveled nearly the entire age of the universe to reach us. To observe them is to look back in time, to witness black holes as they existed when the first galaxies were still forming. Black holes may serve as natural particle accelerators. Their immense gravity and magnetic fields fling particles to energies far beyond what human-made machines can achieve, offering insights into the building blocks of matter. The accretion disks around black holes are among the hottest places in the universe, reaching millions of degrees. These blazing maelstroms transform gravitational energy into radiant heat, outshining entire galaxies in their brilliance. Some black holes hide in plain sight, cloaked by dust and gas. Only infrared or radio telescopes can pierce the shroud, revealing the hungry engines within. These hidden giants remind us that the cosmos holds secrets just beyond our current senses. The collapse of a massive star into a black hole releases gravitational shock waves, altering the surrounding fabric of space-time. These waves carry information across billions of light-years, a silent echo of a star's death throes. Even the smallest black holes pack extraordinary density. A stellar mass black hole could weigh more than our Sun, yet fit into a sphere just a few kilometers across. This compression defies ordinary comprehension, making matter behave in unimaginable ways. Some scientists theorize that the edge of a black hole could be a firewall of energy, incinerating anything that touches it. Others argue it is smooth and silent. This debate reflects how much we still don't know about these cosmic enigmas. Black holes may slow the growth of their host galaxies by starving them of gas. Jets and winds scatter star-forming material, leaving galaxies dimmer and quieter. In this way, black holes act like brakes on the universe's expansion of light. Some black holes may form directly from the collapse of giant gas clouds without passing through a star stage. These direct collapse black holes could explain the rapid growth of supermassive black holes in the early universe. Black holes influence galactic neighborhoods even when they are not actively feeding. Their mass alters star orbits for thousands of light-years, subtly shaping the geometry of galaxies like invisible architects. The idea of a black hole was once ridiculed. In the 18th century, scientists speculated about dark stars whose gravity trapped light, but few took it seriously. Only with Einstein's relativity did the concept gain legitimacy. Today, black holes are central to physics, bridging astrophysics, quantum mechanics, and cosmology. They are both puzzles and answers, forcing us to confront the limits of our understanding while offering glimpses of what lies beyond. The largest black holes may sit at the nodes of cosmic filaments, where rivers of matter flow into galaxies. These locations make them natural hubs, feasting on material funneled to them by the universe's grand architecture. Some merging black holes recoil violently, shot out of their host galaxies. These rogue black holes wander through intergalactic space, dragging stars and gases along with them in lonely exile. Magnetic fields near black holes twist into spirals, channeling energy into jets. These structures are so vast they can shape entire galaxies, yet they arise from physics happening just outside the event horizon. Black holes help forge the heaviest elements in the universe. The violent mergers of neutron stars, often followed by black hole formation, scatter gold, platinum, and uranium across galaxies, seeding planets and life with rare materials. The study of black holes unites international collaboration, from the Event Horizon Telescope's global network to gravitational wave observatories. Humanity must work as one planet to capture the faint signals of these giants. In philosophy, black holes embody paradox. They represent both knowledge and ignorance, proof of relativity, and the breaking point of physics. To contemplate them is to confront the edge of human thought itself. Some black holes feed so slowly that they starve, glowing only faintly. These underfed black holes remind us that even giants can hunger, waiting for their next chance to consume. Others gorge themselves furiously, unleashing quasars that blaze across billions of light-years. These feeding frenzies reveal how galaxies once looked in their youthful, energetic stages. A black hole's shadow is always larger than the hole itself. Light bends dramatically as it skirts the horizon, creating the illusion of a swollen, menacing silhouette in the void. The largest black holes in the universe are titanic beyond comprehension. Known as ultramassive black holes, they may reach tens of billions of solar masses, large enough to fit entire solar systems within their horizons. These giants anchor massive galaxies and clusters, shaping structures across millions of light-years. They are the gods of gravity, their presence so immense that even other black holes orbit them as if they were stars. They are the pinnacles of cosmic power. Black holes may influence cosmic evolution in ways we are only beginning to grasp. Their energy outflows regulate how galaxies grow, preventing runaway star formation that would burn fuel too quickly. Their mergers create ripples that shape the structure of space-time itself. Without black holes, galaxies might collapse into chaos. Stars might burn out too fast, and the universe would look nothing like it does today. They are not just anomalies, they are architects of reality. Even though black holes are defined by their darkness, they are surrounded by regions of extreme brightness. Accretion disks shine so intensely that quasars powered by black holes can be seen billions of light-years away. When the universe was young, these ancient beacons outshine entire galaxies, visible long after the stars around them have dimmed. By studying them, astronomers peer into the early universe, using the hunger of black holes as lanterns to illuminate creation itself. In the distant future, black holes may be the last objects left. As stars die and galaxies fade, only black holes will remain, swallowing what little matter drifts their way. Over unimaginable spans of time, even they will evaporate through Hawking radiation, leaving nothing behind. The universe may end not in fire, but in silence, as the final whispers of black holes fade into eternal darkness. They are the last chapters in the cosmic story. Black holes challenge the boundaries of human language. Words like whole or singularity are metaphors for something our minds cannot truly grasp. They are not holes in the traditional sense, nor are singularities points we can picture. They are places where equations break down, where the tools of thought falter. They remind us that the universe is larger, stranger, and more profound than anything we can put into words. The magnetic fields around black holes are among the strongest in the universe. These fields twist, snap, and reconnect in violent displays, accelerating particles to nearly the speed of light. They are responsible for the mighty jets that shoot from black holes, sculpting galaxies and lighting up the cosmos. The invisible hands of magnetism turn invisible darkness into blazing fire, translating gravity's silent pull into light we can see across time and space. The study of black holes unites the very small with the very large. On one side is quantum mechanics, the physics of particles smaller than atoms. On the other side is general relativity, the physics of stars and galaxies. Both collapse into mystery at the horizon. Black holes are where these two great theories collide, forcing us to seek a grand unification. They are not only objects of wonder, but also crucibles where the laws of reality itself must be rewritten. Some black holes may be wrapped in glowing coronas of high-energy particles, brighter even than the blazing disks beneath them. These coronas flicker unpredictably, like a lighthouse trapped in chaos, sending pulses of X-rays across space. Scientists believe magnetic fields around the hole twist and snap in violent arcs, releasing torrents of energy as particles accelerate to nearly the speed of light. Each flicker is a window into physics beyond human reach, where order collapses into turbulence and gravity sculpts light into art. The spin of a black hole is more than motion, it is power incarnate. A rapidly rotating black hole drags space-time itself around in a twisting dance called frame dragging. This spin can be tapped through processes like the Penrose mechanism, where matter grazing the horizon steals some of its rotation and escapes carrying extra energy. In theory, such engines could outshine galaxies, drawing limitless power from darkness. The hole becomes not only a consumer of matter, but also a cosmic dynamo, its rotation feeding the very universe. When two black holes collide, their dance reverberates across the fabric of space-time. The merger sends out gravitational waves, ripples that move outward faster than any signal we can imagine. Billions of years later, these waves sweep through Earth, so faint they stretch and compress the planet by less than a fraction of an atom. Yet with instruments like LIGO and Virgo, humanity hears them, teeny murmurs of titanic crashes, echoes from cataclysms that reshape the heavens. Every detection is a ghostly recording of black holes colliding in silence across the void. The pull of a black hole is so intense that it bends not only space, but time. As one draws near the event horizon, Time slows to a crawl for an outside observer. A falling star seems to freeze, stretched into eternity as its light reddens into darkness. Yet, for the star itself, time continues normally, until it plunges past the horizon and is lost forever. Black holes turn time into a strange mirror, slow and eternal from one perspective, fleeting and sudden from another. They are the universe's natural time machines. Some black holes are ancient beyond imagination, born not from stars but from the newborn cosmos itself. In the first seconds after the Big Bang, regions of intense density may have collapsed into primordial black holes. These relics, smaller than mountains or perhaps as tiny as atoms, could still wander the universe today, invisible and silent. If they exist, they may help explain the unseen dark matter that shapes galaxies. They would be fossils of creation, remnants from a time before stars, before galaxies, before even light itself. The event horizon is not a wall or a surface, but a boundary in the fabric of space-time. It marks the invisible line where escape is impossible. To an infalling traveler, nothing changes when crossing it. No barrier, no flashy it. The universe has decided their fate. They are cut off forever from the outside world, unable to send even a single photon back. To observers far away, the event horizon is the veil between the knowable and the unknowable, the line where physics itself begins to blur into mystery. The reach of a black hole stretches far beyond its horizon. Its gravity governs the orbits of stars hundreds or even thousands of light years away. Astronomers studying these stellar motions discover the hidden giants at the centers of galaxies, stars slingshot around an empty point, moving at impossible speeds, revealing the massive presence of an unseen master. Black holes do not need to touch their prey directly to control them. They shape entire galaxies, invisible monarchs reigning from the core. Some black holes spin at staggering speeds, approaching the limits of physics. Their horizons bulge at the equator, distorted by furious rotation, while space-time itself is dragged into spirals around them. Gas falling into these maelstroms is whipped into storms hotter than any furnace, igniting winds that roar outward. A maximally spinning black hole is the most efficient engine known, capable of converting matter into energy with unrivaled power. These cosmic whirlpools are not just holes, they are furnaces where space and time twist into fire. Matter falling into a black hole is transformed into a spectacle of light before it disappears. Gas spiraling inward collides and compresses, heating to millions of degrees until it glows in X-rays visible across galaxies. These emissions betray the black hole's presence, shining like cosmic beacons. What appears as an empty void is instead surrounded by some of the brightest objects in existence. Even as they consume, black holes illuminate the universe, their hunger painting the sky with light. Supermassive black holes defy imagination. Containing millions or billions of solar masses, they compress entire galaxies' worth of matter into regions smaller than our solar system. Paradoxically, their tidal forces near the horizon are less extreme than those of small black holes. An astronaut falling in might not feel stretched immediately, yet their influence is colossal, holding galaxies together, shaping their growth, and sometimes erupting in energy that outshines everything around them. They are the rulers of galaxies, invisible emperors guiding cosmic evolution. Hawking radiation, a phenomenon predicted by Stephen Hawking, suggests that black holes are not truly eternal. Quantum effects near the horizon allow pairs of particles to appear briefly. One escapes while the other falls inward, creating the illusion that the black hole itself is radiating energy. Over unfathomable timescales, this leakage causes the black hole to shrink, evaporating until it vanishes in a final flash of pure energy. The most enduring objects in the cosmos are not immortal. After all, they end in silence and light. Binary black hole systems are locked in a gravitational embrace that can last for eons. Orbiting each other, they radiate gravitational waves that drain their energy bit by bit. Slowly, inexorably, they spiral together, closer with every circuit. When at last they merge, the collision shakes the cosmos, sending waves across space-time that travel forever. These unions are among the most powerful events in existence, creating ripples we can now detect from Earth. Black holes do not only consume, they also dance, collide, and become greater. The death of a star into a black hole is not always explosive. Some stars collapse directly, bypassing the fireworks of a supernova. The star simply implodes, its mass condensing inward until even light cannot escape. The process is silent, invisible, leaving behind only a dark husk that hides its power. These direct collapse black holes may have been common in the early universe, seeding the monstrous giants we see at galactic centers today. Not all deaths are dramatic, some simply end in darkness. Black holes are paradoxical engines of both destruction and creation. While they tear matter apart, they also drive the growth of galaxies. Their jets and winds spread heavy elements forged in stars, seeding space with the raw ingredients for planets and life. They regulate star formation, preventing galaxies from burning out too quickly. Without black holes, the balance of the universe would falter. They are gardeners as much as monsters, shaping the cosmos not only through hunger but also through generosity. Some black holes feed so slowly they are almost starved. Known as low luminosity AGN, these black holes trickle matter inward, glowing faintly compared to their ravenous quasar cousins. Studying them reveals what happens when a black hole goes on a cosmic diet, living quietly instead of violently shaping its surroundings. The spin of a black hole may hold clues to its past. A rapidly spinning black hole likely grew through steady accretion, while a slower one may have gained mass through chaotic mergers. Measuring spin is like reading the diary of a black hole, telling the story of how it became what it is. Black holes can serve as natural particle accelerators. Near their horizons, magnetic fields and curved space-time hurl particles to energies far beyond what we can create on Earth. These processes may explain cosmic rays, high-energy particles that slam into Earth from deep space with mysterious origins. In dwarf galaxies, surprisingly large black holes have been found. These discoveries suggest that black holes may have formed very early in the universe, before galaxies had grown. If so, black holes might not only sit at the end of stellar life cycles, but also at the beginning of cosmic evolution. Some black holes are cloaked in thick layers of gas and dust, hiding them from visible light. Only X-rays and infrared waves can penetrate these shrouds, revealing the monster within. This cosmic camouflage means that many black holes may be hidden from our view, silently influencing galaxies while remaining invisible. Gravitational waves from black hole mergers not only confirm Einstein's theories but also open new windows into the universe. Unlike light, these waves pass through matter unhindered, carrying information from places hidden behind gas and dust. They are a new language of astronomy, telling us stories that photons cannot. The temperature near a black hole's event horizon is extreme, but paradoxically, Hawking radiation implies black holes themselves radiate like cold objects. The bigger the black hole, the colder it is. A supermassive black hole would be almost at absolute zero, making its evaporation unimaginably slow. The growth of black holes is as they feed, their radiation pushes back on incoming gas, slowing further accretion. This Eddington limit balances how fast a black hole can grow, like a natural speed cap on cosmic consumption. Yet some black holes appear to have bypassed this, growing faster than theory permits. In dense star clusters, black holes may form binaries that then get ejected by gravitational slingshots. These wandering binaries drift until they eventually merge, sending ripples of gravitational waves across the cosmos. Their expulsions suggest the universe is littered with drifting pairs of invisible killers. Black holes may influence dark matter distribution. Their gravity pulls dark matter inward, potentially creating dense spikes of invisible material near galactic centers. If dark matter particles can annihilate, these spikes might glow faintly in gamma rays, offering a way to study both black holes and dark matter at once. Some black holes may burp after a meal. After swallowing a star or gas cloud, outflows of radiation and winds may continue for years or decades. These echoes of feeding remind us that black holes are not instantaneous in their hunger, but leave lingering scars in the cosmic medium. In certain conditions, binary black holes can align their spins with their orbital motion, producing cleaner, more predictable gravitational wave signals. In other cases, their spins tilt wildly, causing the orbit to wobble before collision. These differences tell us about how black holes formed, whether from isolated stars or chaotic cluster dynamics. The mystery of information loss in black holes remains one of physics' greatest puzzles. If matter falls in and never returns, what happens to the information describing it? Quantum theory insists information cannot be destroyed, but black holes seem to erase it. Resolving this paradox may reshape our understanding of the universe's deepest laws. Some theories suggest that black holes are surrounded by firewalls, searing walls of energy at the horizon that incinerate anything crossing. Others argue horizons are smooth and uneventful. The truth remains unknown, making the boundary of a black hole one of the most hotly debated frontiers in science. When a black hole tears apart a star, debris forms long, thin streams that whip around before falling inward. These streams can circle multiple times, colliding with themselves and glowing as they settle into a disk. Each tidal disruption event is like a cosmic autopsy, revealing the anatomy of a star as it is dissected by gravity. Some black holes may emit mysterious fast radio bursts, FRB, millisecond-long flashes of radio waves detected across the sky. While many FRBs come from magnetars, a few may be linked to black hole activity, perhaps triggered by collapsing plasma or colliding objects near horizons. If so, black holes could be whispering in radio pulses across the universe. Even though black holes are destructive, they also inspire art, myth, and philosophy. To some, they are symbols of death. To others, of transformation. They embody the unknown, challenging our courage to peer into the abyss. Humanity's fascination with them is as much cultural as scientific, uniting imagination with exploration. The hearts of galaxies are crowded neighborhoods, where stars swirl in chaotic orbits around supermassive black holes. Occasionally, two stars collide, forming blue stragglers, hot young-looking stars in ancient regions. Black holes indirectly drive this chaos, stirring the stellar population with their immense pull. The galactic core is not only the graveyard of stars, but also a crucible where new, strange stars are born. A black hole's pull is not infinite at all. Distances it follows the same rules as any mass. Far away, its gravity is indistinguishable from that of any object of equal mass. Replace the Sun with a black hole of the same size, and Earth would continue to orbit unchanged, though life would perish without sunlight. It is only close to the event horizon that black holes reveal their extreme, merciless nature. Some scientists speculate that black holes might preserve the seeds of new universes within them. If singularities represent boundaries where physics resets, perhaps each black hole births another cosmos, disconnected from ours. Our own universe might even be the inside of another black hole, a child cosmos born in the collapse of a parent star. If true, black holes are not merely ends but wombs of infinity, scattering realities like seeds across the multiverse. The sound of black holes, translated from gravitational waves, is eerie and simple. As two black holes spiral together, the pitch rises, creating a chirp that ends in silence after the merger. These cosmic songs, lasting fractions of a second, are the death cries of stars and the birth cries of singularities. They are the first sound humanity has ever heard from the deep fabric of spacetime itself. When matter falls toward a black hole, it doesn't always vanish quietly. Some of it rebounds in massive outflows, heated and accelerated by magnetic fields before it can cross the horizon. These winds can reach thousands of kilometers per second, blowing entire gas clouds away. The black hole eats, but it also spits, reshaping its environment with every breath. Black holes can bend time itself into knots. To an observer far away, objects falling toward the event horizon appear to slow down, frozen in place, never quite crossing. Yet for the object itself, time continues normally, and it plunges past the point of no return in moments. This contradiction shows how black holes don't just bend space, they twist time into a paradox visible across the universe. Some black holes are thought to spin so fast they approach the speed of light at their event horizons. This rotation drags spacetime along in a phenomenon called frame dragging, where nothing can remain still near the hole. Any object nearby is forced to rotate with it, like a leaf trapped in a whirlpool. The faster a black hole spins, the more energy it can unleash in jets and winds, fueling some of the brightest objects in the cosmos. When two galaxies collide, their central black holes are destined to meet. As the galaxies merge, stars and gas funnel toward the middle, pulling the black holes closer. Eventually, they spiral into each other in a slow dance lasting millions of years. The final collision shakes the universe itself, sending gravitational waves rolling outward like ripples from a stone tossed into a cosmic pond. Black holes may act as cosmic anchors, stabilizing galaxies around them. Without the immense gravity of supermassive black holes, stars might drift apart more easily, preventing galaxies from holding their shape. Far from being destructive only, these invisible titans are architects, ensuring galaxies remain bound together for billions of years. The death of a black hole is theoretical but fascinating. Through Hawking radiation, black holes slowly leak energy, shrinking over unimaginable times. A stellar mass black hole would take longer than the current age of the universe to evaporate. But when it does, the final stage is a furious burst of energy, a last scream before vanishing entirely. At the Milky Way center, Sagittarius A** sleeps fitfully. Unlike the raging quasars in distant galaxies, our black hole is quiet, occasionally flaring in X-rays when it swallows a stray bit of gas or dust. This quietness is temporary. If more material drifts inward, Sagittarius A** could awaken, turning into a quasar and flooding our galaxy with deadly radiation. The very first black hole candidate discovered was Cygnus X1. Found in 1964, it sits about 6,000 light-years away and is part of a binary system, siphoning material from a massive blue star. Its discovery was a turning point in astrophysics, transforming black holes from wild speculation into undeniable reality. Some black holes are believed to weigh more than 40 billion suns. These ultramassive black holes defy explanation. Sitting in the hearts of the largest galaxies, their size suggests either rapid early growth or exotic processes we do not yet understand. These giants are so heavy that their event horizons could swallow our entire solar system without a trace. Near a black hole, matter is heated to millions of degrees in the accretion disk. This heat produces X-rays, which we can detect with telescopes orbiting Earth. Without these X-ray beacons, black holes would remain invisible. The brightest X-ray sources in the sky are often binary systems with hidden black holes, quietly eating their stellar companions. Not all black holes live in galaxies. Some are rogue, ejected during violent interactions. They wander intergalactic space, invisible unless they encounter gas or a star. Detecting them is nearly impossible, but their existence is a haunting reminder. The universe may be littered with unseen giants drifting endlessly in the dark. When a star gets too close to a supermassive black hole, it may be ripped apart in a tidal disruption event. Half the star's mass is flung outward into space, while the rest spirals into the black hole, lighting up in a flare brighter than an entire galaxy. These rare events give astronomers brief glimpses of a monster feeding in real time. Black holes may play a key role in limiting galaxy size. Their feedback jets, winds, and radiation can prevent galaxies from forming too many stars too quickly. Without this regulation, galaxies would overgrow, destabilize, and collapse. In this way, black holes are gardeners of the cosmos, pruning their galaxies to ensure survival. In simulations, black holes warp surrounding starlight into glowing rings and arcs. These Einstein rings occur because gravity bends light around the hole, creating distorted images of distant galaxies behind it. Observing these rings helps scientists test Einstein's general relativity at extreme scales, where space is twisted nearly beyond recognition. The concept of black holes dates back to the 18th century, when John Michell and Pierre-Simon Laplace speculated about dark stars, whose gravity was so strong not even light could escape. Centuries later, Einstein's equations and modern astronomy confirmed their existence, proving that these early ideas weren't just fantasy, they were prophecy. If you replaced Earth with a black hole of the same mass, its event horizon would be less than a centimeter wide. The planet's entire mass would be compressed into a speck smaller than a marble, yet its gravity from afar would remain unchanged. This illustrates how black holes aren't necessarily cosmic vacuums, they're just mass in extreme form. In galaxy centers, black holes and stars may form unusual structures like stellar disks, where stars orbit in organized flat planes around the black hole. These disks resemble miniature galaxies, hinting at the order hidden within the chaos of galactic core. Such systems show that black holes are not only destroyers but also organizers of stellar architecture. The first image of a black hole's shadow, captured by the Event Horizon Telescope in 2019, was a monumental achievement. Thousands of scientists, dozens of observatories, and years of data produced a glowing ring around a dark center. This was humanity's first direct glimpse of an event horizon, the silhouette of nothingness itself. Black holes can sculpt galaxies with their jets, drilling holes in interstellar clouds and pushing matter outward for hundreds of thousands of light-years. These jets aren't simple streams of gas, they are cosmic chisels that carve the very structure of space around them. The cavities they leave behind in galactic plasma are so vast they could fit entire galaxies inside, silent reminders of how invisible giants shape everything in their reach. Some black holes exist in trios, systems where three invisible monsters orbit and tug at each other in a chaotic dance. Unlike the stability of binary pairs, these triads are unstable and unpredictable, sometimes ejecting one black hole like a slingshot, while the remaining two merge. These events are rare but powerful, scattering black holes across the cosmos and seeding future collisions that send ripples of gravity rolling across the universe. At the edges of black holes, matter doesn't always plunge inward smoothly. Sometimes it clumps, forming hot knots that whip around the hole at a fraction of light speed. To a distant observer, these bright knots flare and dim in repeating cycles, like a lighthouse sweeping across the cosmos. By tracking these flickers, scientists map the hidden landscape of gravity near horizons, watching light itself twist under the invisible hand of spacetime. The earliest black holes may have shaped cosmic reionization, a transformative era when the first stars and galaxies ignited and filled the universe with light. Their furious feeding could have released torrents of radiation, clearing the fog of neutral hydrogen that once cloaked the cosmos. Without their hunger, the newborn universe might have remained hidden much longer, its galaxies buried in shadow instead of blazing forth in light. In galactic clusters, black holes don't just rule, they regulate. Jets from supermassive black holes pump heat into surrounding plasma, preventing it from cooling too quickly. Without this feedback, gas would collapse into stars too rapidly, exhausting itself in a flash. Instead, black holes extend the life of galaxies, acting like thermostats for the universe. Their violence is paradoxically what allows cosmic structures to endure across billions of years. There may be wandering supermassive black holes adrift in intergalactic space. Stripped from their host galaxies during mergers, these giants, carrying millions of solar masses, drift silently through the void, invisible except for the faint trails of stars they sometimes drag along. Entire star systems may orbit these homeless titans, traveling through the dark between galaxies like ships adrift without a port. Some black holes grow faster than theory allows, as though they've broken the rules of physics. Astronomers have discovered quasars powered by billions-mass black holes. Less than a billion years after the Big Bang, normal accretion alone cannot explain their size. Perhaps they were seeded by colossal direct collapse stars, or maybe they swallowed matter in ways we don't yet understand. These anomalies challenge us, daring us to rewrite the story of cosmic growth. The environments near black holes may forge exotic particles. As magnetic fields whip particles to near light speed, collisions produce showers of high-energy, neutrino-tiny, nearly massless particles that slip through matter as if it weren't there. Detectors buried in ice and underground caves on Earth have traced some neutrinos back to black holes, linking these invisible ghosts of physics to the darkest giants in the cosmos. Black holes sometimes trap stars in long, slow deaths. Instead of being shredded all at once, a star may bleed over thousands of years, shedding streams of gas into the hole. These events, called partial tidal disruptions, create glowing tails that flare again and again as the star makes repeated passes. Each orbit is like a cruel ritual, a reminder that the star is doomed but not yet free from the monster's grip. In some regions, pairs of black holes form inside dense stellar clusters, born from the collapse of massive stars. These stellar mass black holes drift together, sink toward the center of the cluster, and eventually merge. The process repeats over eons, creating heavier and heavier black holes. Some scientists believe this hierarchical merging is how intermediate mass black holes form bridges between stellar corpses and supermassive giants. For civilizations, black holes may be both peril and opportunity. A nearby supernova birthing a black hole could irradiate a planet with deadly radiation, sterilizing entire biospheres. Yet, advanced beings could use black holes for energy extraction, time dilation experiments, or even as gateways if wormholes exist. To such civilizations, black holes are not monsters but tools machines carved out of gravity itself. The edge of a black hole glows with a photon sphere, a ring where light orbits endlessly. Photons trapped here circle again and again before some escape, creating a halo visible to distant observers. This sphere is unstable. Any small nudge sends light inward or outward, but its existence shows just how profoundly gravity reshapes space. Around black holes, even light must bow to gravity's rule, forced into eternal loops before fading into freedom or falling into darkness. Some black holes are embedded in binary star systems, partnered with a still-living star. The black hole siphons gas from its companion, forming a disk that glows in These systems flicker like cosmic lanterns, betraying the presence of an otherwise invisible predator. Over time, the companion star may be entirely consumed, leaving only the black hole behind, fatter, brighter, and hungrier than before. The birth of a black hole may sometimes unleash a gamma ray burst, the most powerful explosion in the universe. In seconds, a collapsing star channels more energy into narrow beams than our sun will emit in its entire lifetime. These bursts sweep across galaxies, sterilizing everything in their path. Yet they also signal creation, a black hole born, the old star erased, and a new abyss opening in the fabric of space.